Okay, well, welcome to the Géant showcase. Today we'll be hearing about the automatic configurations of systems, the case of Puppet, and this is going to be presented by our colleague Andrea Biancini from Géant, Consortium Géant in Italy. Please, for the rest of the participants, can you switch off your webcams and microphones? You can ask any questions you like in the chat window on the right-hand side if necessary, and if need be, we can get Jim to re-enable your microphone later on. So please enjoy the show, and over to Andrea.
Okay, thank you very much and welcome everybody. I am Andrea Biancini and I work for Consortium Géant in Italy. Today I'm going to talk about an automatic configuration system, in particular Puppet, which is one of these systems, and we are going to present very briefly some technical detail about what is Puppet, how it can be used, and which kind of problem it can solve. During the presentation, to see what Puppet is, which is its purpose, how and when it can be used, and we will see also where we inside GAR started to use Puppet to solve a problem, a very specific problem into one of our projects. After that, we're going to see a very brief basic principle about how Puppet works and how it has been built and how it can be used in real projects. And this is particularly interesting, even if it will be very, let's say, not particularly into the details because of time reason, but it's interesting because Puppet has quite a peculiar logic and needs to be understood before you can start using it. And after that, I will also show a very brief demo. In this demo process, I will show how it is possible to use Puppet to install and configure Apache HTTPD web server on a Windows and on a Linux client, so on a Windows and Linux machines. We will see how we can build such a demo, and to build this demo we will leverage existing modules so that we do not have to reinvent the wheel and use what is already freely available and ready to be used into existing projects. Besides, we will see also what really needs to be developed to implement this kind of use case scenario and to have a full installation of the Apache HTTPD on our servers. Besides the demo, I will also provide some link and reference to additional material, because for sure the demo will be very, very quick, but you will have time to go into the details of what we will be doing here in a different moment, also offline to the presentation. So starting with Puppet, what is Puppet? Puppet is a framework which is born to automate repetitive system administration tasks. What does that mean? This means that Puppet has the goal to automatize some repetitive tasks that we usually execute many times when we need to provision, install, or configure IT software or systems. So in the example we were saying before, during the demo we will see how we can use Puppet to automatize the installation and configuration of an Apache HTTPD web server, which is probably something we have been doing as a system administrators many times during our work and career. Puppet is one of these tools and is able to automatize many repetitive tasks, and is a commercial software which has also an open source version. The open source version, which goes under the Apache 2.0 license, is a license that permits you to download and use the Puppet software mostly in all its components, but of course without any supports from the Puppet Labs group. If you decided to use the open source version of the software, you will only have support from the community. This is, just for your information, the kind of software, the kind of version of software we decided to use in GAR, also to support production projects. Puppet is available basically on any operating system, but mostly on Linux, where it has been developed and built, but it's available also on Windows and on Unix, mostly BSD and Solaris. So as you can see, Puppet can be used to provision and configure IT servers which run different versions of operating systems, so not only Linux systems, but also Windows and other flavor of Unix. So, how and when we can use Puppet in our projects? Well, Puppet can be easily used to automatize, as we said, the provisioning and configuration of IT servers. We were taken as an example, the example in which we want to do an automatic installation of an HTTPD web server on one of our servers, and in this case Puppet can help us automatizing repetitive tasks in a more structured and well-defined way than by creating script that automatize the commands we do by hand on the shell. The overall mechanism of Puppet is the one depicted into this slide. As you can see, the node, which is, let's say, the client machine into the Puppet dialog, will contact one Puppet master. The Puppet master is the single point inside our network where all the configuration and, let's say, software description and configuration is stored for the whole network we are managing and administering. So each client can contact the Puppet master providing some information. As you can see, the node, when contacting the Puppet master, will provide some facts. The facts will only be information about some basic characteristic of the node itself. For example, the operating system it is running, the version of the kernel it is running, its host name, its IP address, and informations like that. Based on this information, the Puppet master will be able to construct a catalog, which is a set of instructions and configuration instructions to be sent back to the node. This catalog will contain all the desired configuration for the node. When the Puppet master will send back the catalog to the node will then execute all the instruction contained in the catalog and will change its configuration to satisfy the requirements expressed in the catalog. So, for example, in the example we were describing, the node will receive a catalog asking him to install a specific package of software and then to configure it in a specific way. So the node will execute the needed operation, so the installation of the software and the configuration, and then will communicate back to the Puppet master a report. This report will contain information about how the software has been installed, if there has been some problem or error during the installation process, and so will permit the Puppet master to have a complete state of the configuration status of all the servers that connect to it. This report can then be stored into a Puppet component or a third-party software if you already have some third-party tool that collects all the information about your network. So as you can see with this round circle, we can have a mechanism that is able to automatize the installation and configuration of servers in our network. And this is what Puppet is really good at doing. As we said, we can do something similar using scripts or automatizing in different ways the deployment and installation of our software. But what Puppet does is that it permits to do this in an operating system agnostic environment and by specifying configuration steps in a standard ways that different installation and different configurations can share the same representation. The Puppet master, in fact, will act as a single point containing all the description of the configuration state of the whole network we are managing. Moreover, this mechanism is able to respond very positively to errors, and so will present information about what's not going as wanted. And so, if there are any problem, it permits the system administration to be alarmed and to, let's say, operate accordingly to solve the problems. When we develop Puppet modules, we need to concentrate basically on step 1 and 2 of this diagram. So we need to understand which facts the node is providing to the Puppet master, and then we need to concentrate about how we can build a catalog for that specific node, instructing it to configure all the needed software we want it to install. In particular, these operations are done taking into consideration the basic principles of Puppet. In Puppet, when we build a catalog, we need to consider that everything is described as a resource. What does that mean? That means that every single piece of configuration of a system is described as a resource, and so we may have resources like, for example, software packages, like files, like processes which may be running or not running on specific machines. And if you're dealing with Windows, we do have resources to deal with the Windows registry, the services table of Windows, and so on. So Puppet models every piece of configuration as a resource and then defines transitions amongst these resources. So every resource may have an initial state, which is the state where the resource stays at the very beginning of the process, and then a desired state, which is the end state we would like to have on the machine at the end of the configuration. Puppet permits to describe transition amongst these states, and so executing this transition, Puppet is able to configure the machine so that from the initial state goes to the final state. The final state we described in the catalog is the desired result, so the desired configuration we want to provision for the machine. One thing which is very important to be taken into consideration is that inside Puppet, transitions among resources are not usually executed in a definitive order. If we want some transition to be executed before another, we need to explicitly say that into our code. Otherwise, Puppet will try and execute all the transitions available that can be executed without a specific precedence. Going back to our example, we said that in the demo we will see how to install an Apache HTTPD web server. So if we have to model it inside Puppet, what we have to do is that we have to at first to think about which resources are involved. Talking about a web server, the resource involved will be the HTTPD package. If you are on Linux, we will talk about an RPM or a deb package of the Apache 2 web server. Then we will have different resources describing the configuration files. So for example, the file /etc/apache2/apache2.conf will be one resource in our Puppet modelization. And then we will have, for example, one service, which will be the service Apache 2 on Linux or with a different name on Windows, which will be the service of the web server that will be used to start the web server so that the machine will start operating as a web server machine. Given these resources, we need to describe the transitions among them, and so talking about, for example, the first resource, which were the deb package, the software package for Apache. The transition could be a transition moving from not present to installed, and that transition will execute the operation of installing the software package. After the installation, which can be done on Linux in one way and on Windows in a different way, we will have the configuration of this package. The configuration of this software will be done by executing transitions on other resources, so by modifying the content of the configuration files. And then at the end, we will have the starting of the service, so the last resource involved will be the resource modeling the service at the operating system level, and the transition executed will be from not running to running. So we will execute the service Apache 2 start, for example, that will start the web server and make it running. So all these resources will be modeled inside our recipes, so inside our code inside Puppet. And then the client machine will execute them so that the state can be moved from a fresh installed machine without any additional package, so for example an Ubuntu with no particular package or software installed, to a version of Ubuntu which has an Apache HTTPD configured and running. We may also elaborate a little the Puppet recipes to, for example, install ASSL certificates and install web applications so that our web server is automatically provisioned to support and provide a specific application. So inside GAR, we started using Puppet because we had a very specific problem. We decided something like 1 year ago to implement a cloud service that should be able to provide an IDP, which is a very complex specific software component in the field of identity federations. And we wanted to provide this IDP, this piece of software, in a sort of as-a-service way, typical to the cloud business model. To do that, what we wanted to achieve, a mechanism able to give our organization, our partners, the possibility to operate inside our identity federation without having to taking care about too many technical details. So by providing a running server as a service, we expected our let's say organization, our partners, to be able to collaborate into the identity federation more easily. To provide such a complex piece of software as a service, the first option we had in front of us was to have a very large system support division which could execute all the manual installation of this software by hand. In this case, as you can see in the left part of this slide, we estimated times which were very long. So we estimated something like 2.5 hours to install one single server to be irrogated as a service into our cloud environment. So we decided to find possible different solutions to automatize and, let's say, reduce the timing of this operation and also reduce the number of possible errors or misconfiguration we may have in our systems. We achieved these results by at first using a virtual infrastructure based on OpenStack. I mean, this is not the subject for this topic, for this showcase. But then when we have this, let's say, virtual machine ready to be installed and configured, we also searched for a tool that could permit us to install all the software prerequisites and all the software components to execute an IDP in an automatic way. We found that we can achieve this goal by using Puppet. So in our recipes into this project, we have some Puppet configuration which is able to install the Tomcat web server, the LDAP server, a MySQL database server, and then configure all these components and provision the Shibboleth application which implements actually the IDP we're going to provide as a service. All these steps and all these activities are automated, and so they are executed by a software instruction, and so all this installation process lasts less than 2 minutes, and the possibility of errors are really reduced. Okay, in our demo we are going to see something similar, but for sure simpler, and we're going to see how it is possible to install, as we said, an HTTPD web server on a Linux and on a Windows client. I wanted to show you the two installations on Linux and on Windows just to, let's say, communicate to you that Puppet is able to contain, describe and contain the configuration of a whole network system, not only the Linux servers or our backend servers, but we can also use Puppet, for example, to provision desktop clients to our users, if we have many of them, and Puppet is able to automatize the management of this system, this Windows system, as well as if they were Linux systems. So in our architecture, in our environment, we will have one Puppet master, which will be the server for our interaction, and then two clients, one Linux and one Windows client that will try and install Apache HTTPD. So in this slide, I will present some, very briefly, not into detail, what I needed to implement to realize this demo, and so to obtain the installation, the automatization of the installation process. As you can see, I decided not to start from scratch, and so managing all the possible resources, the installation of the package, and the configuration of all the files that needs to be configured for having an Apache HTTPD web server running, but I decided to use existing modules. So for example, in the first dot of this slide, you can see that I installed with the command puppet module install different modules. In particular, the last one, the Puppet Labs Apache, is a module which is already present and is open source and permits to install an Apache web server on a Linux machine. On Windows I had to do something different, and so as you can see I had to install different modules. In particular I installed the Puppet Labs registry, which is able to interact with the Windows registry, and then the module Windows package, which is able to execute and install Windows packages onto a Windows system in a similar way to what we can do on Linux with apt or something similar. And then I decided to use a netshare module, which permitted me to obtain all the software needed to be installed on my Windows machine from a common location inside my network. So when we create a Puppet recipe, we do not have to build nothing from scratch, but we can leverage existing software and existing modules already developed by different teams, and all of them released as open source and freely usable in our projects. Then, after having installed these modules, I created one class which is not completely present here due to time limitation. I didn't want to explain all the code, but as you can see inside my class, which I called Apache HTTPD, I do a simple if switch, and so into my class I go and evaluate the kernel fact provided from the node machine connecting my server, and if that variable contains the Windows string, I assume, because this is the specification, that that machine is running Windows, and so I will execute the installation of Apache on Windows. Otherwise, I will execute the installation of Apache as if the system connecting is a Linux system. I know we may have different systems, Solaris, BSD or whatever, but in this very simple case I will only install Linux on Windows and Linux. So as you can see, even if this code is very simple and does not present the specific parts about installing the software, you can see that in our recipes inside Puppet we can use facts from the nodes, and so we can conditionate the configuration of the client machine depending on some information he is providing to us. Okay, after having created this class, also with implementation you cannot see because I put suspension points into this slide, I created a site pp, which is the common place where all the nodes of my network are described and configured. So as you can see, after having imported my class, I define at the point above, I have created a node declaration saying that the two hosts identified by their host name, which are Windows client.local and Linux client.local in my demo environment. These two nodes identified by their host name will need to install the class Apache HTTPD. This piece of code is not simplified. It's the exact code I used to install Puppet, to install the Apache web server on my Linux and Windows servers. So as you can see, after we have created the right classes, or after we decided which modules to use, the Puppet configuration code can be very easy and small. Having created this environment on my Puppet master, I then executed the Puppet agent, so the client side of Puppet, on Linux and on Windows. Into this slide, I wanted to present you some very brief video showing you the installation process. I then will guide you through the video showing the installation into a Linux machine, and then if you want we can also see the Windows machine, which will practically be the same. So on Linux, as you can see, I have a freshly installed Ubuntu server here, and as you can see from my comments here, I will show you that there is no package Apache installed, and there is no service Apache Duo available on this machine. Then I execute Puppet after the configuration I described, and with this command, Puppet agent --test, and test indicates a set of common parameters that needs to be passed to Puppet to do all the installation activities. We will see the process starting. As you can see, the automated process is completely executed and logged. So here into this window with the colored output, we can see what is happening, and we can also see if there are any problems. If you have the opportunity to read what is present into the screen, you will also see that what Puppet will do for us is that it will install the Apache package, deb package in this case, since it is an Ubuntu, and then we'll configure all the files and start the Apache server at the end. So in less than 30 seconds, we will have Apache installed on our server, and as you can see now, the packages shows the Apache 2 package available, and will also show the service running. If I use a text browser now to connect to my local host on port 80, as you can see, I can see the welcome page of Apache. So in this very short 30 seconds, Puppet configured and installed Apache on our machine without any specific web application available on it. But I mean, it was a demo just to show you the possibility of Puppet. Something similar could be available on Windows. Now, for time reasons, I will skip this part, but trust me that if we would see the video about Windows, we will see practically the same thing. We will execute Puppet agent --test, and on Windows, the specific Apache package will be installed, and the service will be started, and opening Internet Explorer or Firefox, we will be able to see the welcome page from Apache. So I know that this presentation was very brief and quick, so we didn't have time to go into the details about the implementation, but I wanted to provide you all the available material if you want to see what really Puppet is doing inside under the hood. You can find all the material for this demo into this GitHub repository, and from this GitHub repository you will see for sure the recipe I developed, which are the one presented into this slide, but with all the parts implemented. But we will also see some guide, step-by-step guide, that will help you repeat the demo process onto your environment, physical or virtual, as you prefer. If you may have any problem, or if you want more additional information, you can always contact me, because my demo was developed on a virtual environment on VirtualBox, so in case I can send you the virtual machines and you can also see them running on your VirtualBox environment. So basically, this closes my presentation. What I wanted to show you is what is Puppet and how it can be used to do a very simple configuration task like installing an Apache web server. I also presented you how and why we used it on GAR, just to show you how complex can be the configuration process. We installed for sure a software which is way much more complex than Apache web server, and I mean, by automatizing this step, we reduce the errors and provide economies of scale in our provisioning of the service. Now, if you have any questions, I'm available to answer.
Well, that's excellent. Thank you very much, Andrea. If anybody has any questions, you can type them into the chat box on the right-hand side. And I think there's a couple of people typing. There you go. Please ask away, Dick. Can you see the questions on the right-hand side, Andrea?
Yes, I see that they're asking a question. It's writing. Dick is writing.
Coming up, there you go. That's excellent, and it's great to see the use case as in support of the application there. So thank you for that. It's explained a lot to me, who is perhaps the least technical of all your today's audience.
So the question is about what size does this setup start to make sense? Well, we started to use Puppet in our environment where we plan to have our project of providing IDPs servers to our let's say organization collaborating with us, and we plan to have 50 systems. So we are going to use Puppet on a total number of systems which is up to 50. The point here is that, I mean, it depends, because you can have different usage of these systems. We decided to have a fully configuration automatized, and in this case, I mean, also small number of managed server can be relevant to the use of this tool. In other cases, you can also decide to have only some aspects, for example, security package provisioning or security configuration, firewall configuration, IP tables, and all the servers automatically configured by Puppet. And in this case, I mean, Puppet can be used also to provide a higher level of configuration of your systems, even if you have a higher or a lower number of servers. What we decided to do is that, I mean, we decided to use it because providing the same service in a manual way or by using scripts would have been much more difficult and much more costly. I'm not sure I answered the question. I hope so.
And there's a question from Simon. Oh, so Dick, sorry, I didn't question check with you, but one question from Simon there.
It might make sense with just one system because you have to configure the server in one place. Yes, that's real. The other point of advantage of using Puppet is that you have all the configuration of your systems into one single place. And so, I mean, they are easily manageable and so on. Another thing I would like to underline here is that we used Puppet into a cloud environment, and the reason for that is that usually on clouds, I mean, the way we provided cloud services, we start from, let's say, snapshots of virtual machines, which are general purpose, so which install Ubuntu or whichever version of Linux you prefer. And that's it, and then this snapshot can be used to provision different services. So we can use that Ubuntu installation to provide a web server, the same Ubuntu installation to provide, I don't know, an LDAP server, the same installation to provide a MySQL server, and so on. The difference here is the configuration that is being done on the machines that is done automatically by Puppet by us. Yes.
Question there from Toby.
Yes, I have a question about the -- test part of the command. Now, the test part permits you to shorten the number of parameters you have to pass to Puppet. That -- test signifies that the Puppet agent executes a full synchronization with the server with a normal level of logging and I mean with a normal level of let's say warning if something is not working. So the name test may be misleading because we're not actually doing a test, we are actually executing Puppet and installing software on our machine and configuring it, so it's not a test, it's something real happening, but that's the name that Puppet Labs decided to call this set of parameters. Yes, you're welcome. This name really make me smile anytime, but that's the way it is. Yes, so the question is if there is also a real test option, so the possibility to execute, for example, a dry run of the application of the catalog into my environment without actually executing the configuration on my machine. And yes, there is an option, I do not remember it by heart, but there is an option that can be executed when you call Puppet, and this option -d, if I remember correctly, but I'm not sure about that, will only show you which operation will be executed on your system without executing any of them actually. So it can be used to dry run or verify that the catalog is correct before modifying the real configuration of the server.
That's excellent. Have we got a question coming from Jens?
Yes. Ah, that is called no-op. Okay. Further comment from my end. I found a bunch of. Well, yes, I'm waiting for the last part of the questions. With this very first comment, I do agree. I mean, Puppet has a very specific logic inside because, as I tried to explain, it does not. It's very counterintuitive. Yes, what I find very counterintuitive is the fact that there is no precedence in the execution of commands, so let's say in execution of transition amongst the resources, if you are not specifying explicitly them into your code. This could lead to many errors because, I mean, we are used to create programs or scripts where one instruction is executed only if the one before are executed correctly. This is not the case of Puppet. If you want to obtain this way of working, this behavior, you have to explicitly explicit it into Puppet, and it is possible, but it's counter the logic of the software itself. It may be counterintuitive, and it also may be difficult at the beginning to start working with, but I also think this is a good way to simplify the problem of having a complex configuration deployed. because when we deal with a complex configuration, we may have some part of the configuration done correctly, while there are some misconfigurations somewhere else, and if there should be any dependency, you may end up with a completely non-working system. In this case, you may have part of the system working and part of the system not fully configured. You will have warnings and messages coming from the configuration process telling you that this specific part of the system was not configured correctly, but what can be done was executed. Yes, Chef is another tool of those doing automatization of provisioning, and Chef is based on a completely different approach. So the approach of Chef is much more, let's say, procedural. So you have one operation, then the next, and I mean, it can be somehow easy to start with Chef on some point of view, but we decided to use Puppet because I don't know, basically because of opportunity reasons. We found it very valuable. It's been used also in commercial environments very often, and it was I mean, it could solve our problems. So. Okay, so Yushan is telling me that Puppet is probably Chef is probably even more difficult to understand in the first place. So I mean,
nice one. So I think
every tool may have its point of force, point of weakness. So I mean. Ansible, I don't know it. Okay, I appreciate the comment. I do not know Ansible in particular, which is, I suppose, another tool to automatize software provisioning and system provisioning, let's say. But it could be interesting to look at it.
I think we're going to run out of time now, Andrea. Thank you very much indeed. Thanks to everybody that's contributed to the discussion as well. Dick, if you've got a last question, please ask away. But otherwise, I think that's about time to wrap up. It's been a great session. There's a quick question there from Dick for you, Andrea.
Yes, the question is if this process works better if you have a more homogeneous environment. Well, this is true because the complexity of the release types you have to build are more. I mean, are less. The recipes are less complex if you have an homogeneous environment. But you can use it the same way also in heterogeneous environments. We didn't use it this way, but we could. I mean.
Well, excellent. Thank you. That's answered quite a few questions there, and I think we're just about run right out of time. People, thanks for your contributions. Thank you very much indeed, Andrea. It's been brilliant. It's been great to get some information out across the community again. Thanks for taking part, and we'll catch you all again. So, Jim, back to you in the studio, as they would say, and if you want to switch off, thanks.